Hey there, this is Travis Kassab, and by the end of this video, you'll have an idea of what technology is and where it's all going. Because I don't know about you guys, but I get hit with a lot of technology news in my news feeds, in my social feeds, and it's very difficult to keep track of everything. So this is what I'm doing with the macro tech stack. It's my best attempt at zooming out and looking at technology as a whole. I wanted to see everything all at once. But then also, if you're a product builder or you're an entrepreneur, you would want to know where technology is heading so that you can position yourself accordingly and so that you can pursue the products that you think will be important in 5 or 10 years now. And that's how you get ahead of everything. So starting at the very bottom, we have energy. This is the most fundamental technology there is. Energy powers literally everything we do, and high energy consumption has a good and it has a bad side. The good side is that all the modern amenities that we enjoy, like abundant food and modern medicine, would not be possible without our high energy consumption. We wouldn't be able to travel by car or by plane without burning fossil fuels. Of course, the downside to this high energy consumption is that our fuels are dirty and they pollute the environment. But there is a new paradigm of energy on the horizon. This is the clean energy paradigm, which is renewables like solar energy and also nuclear fusion technologies. And the great news is that the direction away from climate disaster and fossil fuels and towards an unimaginable abundance of clean energy is the same direction. And we're making rapid progress towards this clean energy paradigm. We have solar energy, which is starting to be adopted more and more. This was driven largely by the technological improvements in solar energy. Cost of solar cells has decreased by something like over 99% over the past 50 years, while also getting much more efficient in generating much more energy per panel. Solar energy is going to triple within the next 3 years. And when it does, it's going to overtake fossil fuels and coal as an electricity producer. And the other clean energy I want to talk about is nuclear fusion. Governments have been slow in developing nuclear fusion, but this is starting to change because there's a startup ecosystem that is forming around nuclear fusion technologies. So now we have over 30 private companies that have received over $5 billion in funds to develop nuclear fusion at scale. So you have billion-dollar spend from governments, and now you have private companies who are competing with each other in the free market to bring nuclear fusion generated electricity into the grid. Now, nuclear fusion, it's a much longer time frame. This is more of like a 2040, 2050 kind of thing. I think that it's something that you're going to start to see more and more of. Data is the next innovation platform. It's sort of the most abstract because you think, what is data? But the overall story with data is that it's increasing exponentially. The vast majority of this data is unstructured data. So think of all the images and video and audio files and text on the internet, and how do we search through this unstructured data right now? So right now we manually search engines ourselves, but in the future we're going to have AI agents go out onto the web for us, find exactly what we're looking for, come back with multiple sources, and summarize those sources in the exact format that we want. And also AI allows for media searches as well. So AI can see what's in video, it can hear what's in the audio files, it can see what's in images, and then we can type out a search and find an exact point in a song or exact point in a movie because AI can now search through all of this unstructured data very quickly. Now we're on to materials, and I know most of the people who follow me are digital product designers, so they're thinking, why are you talking to me about physical materials? Well, let's talk about what material science is. Material science takes a naturally occurring material and then changes it into a material with special properties that make it good for a specific application. So we make metal that is both lightweight and strong, and that enables aircraft. And then we have these special materials called semiconductors, which makes all of our computers possible. And then we have the biomedical devices that we're starting to implant into our bodies. And this requires biocompatible polymers, which is like a plastic, but your body doesn't actually fight the plastic because it's compatible with biology. The traditional paradigm of material science has been to modify materials at a macro level, not at a molecular level. But this is starting to change because there's a trend where we're starting to engineer smaller and smaller materials, and now we're down to the atomic level. These are called nanomaterials, where a scientist can build a material from the bottom up, atom by atom. And this gives scientists extremely fine-grained control of material properties. Graphene is a great example of a nanomaterial. Graphene is just a single layer of carbon atoms, and it's 1/100,000th smaller than a human hair, but it's 200 times stronger than steel, and it also has great thermal and electrical properties. So this allows for things like stronger composites, but also it's going to allow for flexible electronics and then ultra-sensitive sensors. So this will allow for all sorts of different new products like biomedical devices to be built on top of it. Now, one of the most well-known trends of all in technology has been Moore's Law, that we can double the number of transistors in computer chips every 2 years. And this trend has been going on for over 50 years now, and Moore's Law has been extremely predictive in what we've been able to do with our computer chips. But Moore's Law is starting to come to an end. We're coming close to the physical limit of the number of transistors we can cram together. Overall, it's unclear how much better our CPUs and GPUs will get from here. And we have these increasing computation demands. We want better AI, we want smarter AI, and so how do we get to the next level there? And this has to do with the future compute paradigm, which is quantum computing. So quantum computing is unlike classical computers. It doesn't rely on more transistors. It relies on quantum mechanics that enable all sorts of things that classical computers simply cannot do. So quantum is still in its early days. It's very immature compared to classical computers, but it's gotten a lot better in the past 5 years. It's gotten over 10x faster over the past 5 years. And so if this trend continues, people think that we're going to see quantum computing become better than classical computers in the next several years. So quantum makes totally new things possible. It's going to make smarter AI possible. It's going to change how we design medicine and new materials, and then also logistics optimizations. How do we get something from point A to point B in the most efficient manner possible? This is all going to change with quantum computing. All right, now let's talk about internet connectivity. I think a lot of you will be surprised that 30% of the world still does not have access to the internet. I was very surprised when I read this fact. So that's 2 billion people who cannot access the modern economy or access cheap online learning. And also 5G, which is the most recent generation in cellular connectivity, has only been adopted by 20% of the world. These are the people who are in the major metropolitan areas, have access to 5G, but still the vast majority of the world does not. And so when you take all this together, you realize that fast and cheap internet connectivity is by no means evenly distributed throughout the world. But we're moving into a world where everyone on Earth is going to be connected with gigabit connectivity speeds. Gigabit connectivity speeds is like the ability to download a movie in 1 second on your cell phone. So how is this going to happen? Well, first of all, satellite is a big part of the story. So you have companies like Starlink who are launching satellites into lower Earth orbit, and satellites are starting to be able to broadcast down internet connectivity to areas that didn't have access before. So satellite internet connectivity is going to fill in all of the gaps that are left by current land-based services. And the other part of the story is that 5G is going to continue its rollout, and more people are going to get access to its gigabit connection speeds. So by 2027, half the world and over 4 billion people will be connected with 5G. Now, something really interesting to think about as a product designer is that every time cellular connectivity has gotten faster, a new mobile experience has been unlocked. So 3G unlocked simple internet browsing and email, right? These are givens and were like the most basic cellular internet connectivity you could have. But then when 4G came along, it enabled us to stream HD video. It enabled mobile banking and mobile shopping. And so 5G with its gigabit connectivity speed feeds is going to enable us to do all sorts of new things. We're going to be able to stream 8K video, stream VR experiences. These immersive experiences will be able to come straight into our devices. And then also we're going to be able to connect to thousands of IoT devices at once. There are going to be sensors in our homes, sensors in our cities that we're going to be able to connect to and receive data from. So now we move on to networks, and the most famous, most well-known network is the public internet, of course. But the interesting thing is that the internet is still evolving and it's still changing even as you watch this video. So you may have heard of Web 3, and so you think, okay, Web 3, well, what was Web 2 and Web 1? Well, Web 1 was a website. So the first internet was created, and we've all gotten the ability to go and browse websites. And now Web 2 was the rise of social media and cloud services. These centralized the internet, but made it much more user-friendly. So Web 2 has given us the ability to post our thoughts, but it's come with the problem that just a few big tech companies like Meta, Amazon, and Google control how billions of people access the internet and interact with the internet. So Web 3 comes along, and yes, Web 3 has a cryptocurrency component to it. It started with Bitcoin and then Ethereum, and now there's thousands of other blockchains. But Web 3 is really much more than cryptocurrency. It's much more than speculative tokens that you would want to invest and make money in. Web3 completely reimagines how we interact with the internet, and it makes ownership possible for the Web3 user. So I think of Web3 as creating this sovereign, free digital citizen who really owns their application data, their digital identity, and their possessions like, yes, cryptocurrencies and NFTs. And Web3 is being adopted rapidly, so it looks really similar to the adoption of the internet in the early 90s. It's estimated that around 100 million people are Web3 users right now, but by 2030, we can expect over 1 billion users to be in the Web3 ecosystem. Okay, now let's talk about algorithms. Algorithms is a fancy way of talking about artificial intelligence. What artificial intelligence is at its base level is mathematics. So you give the algorithm some input and it gives you some output. Now, artificial intelligence and assistants have been working for you already for decades, and you probably just haven't noticed them. So there's an AI assistant that's always been in Gmail that detects whether or not an email is likely to be spam or not. And if it's likely to be spam, then it moves it into your junk folder. And then we have content platforms like Spotify and Netflix, and we have these AIs who are watching what you're listening to and watching, and then recommending content based on these things. And so these are AI algorithms at the base level that are automating these things and making it possible to add these convenience features in. But these features were, again, convenience. They weren't really earth-shattering by any means. Now we're getting into this era where algorithms are starting to surpass human beings in terms of capabilities. So this recent generative AI era has made it to where now we have AI that is better than the average human being at language and image recognition tasks. Now we come to the part where we look at how AI has improved over the past 30 years. And if you follow that trend line, you see that by 2030, and some experts really believe this, that we'll have achieved human level general intelligence algorithms. So we'll have AI that is as smart as humans are and can do pretty much everything that humans can. So I think this is going to automate most white-collar work that exists today. Things like accounting or maybe even product design, and AI is going to be able to do that for us. And I know this arouses really strange feelings, and it's a scary thing to think about, but it's also an exciting thing to think about. And I think that if people reflected on their white-collar jobs and realized that a lot of the tasks they do are monotonous, a lot of the things that they do in their jobs they don't really like, and think about, well, if we get into a paradigm where AI can automate all this, then your time is going to be freed up to do only the things that you want to do. And so I think humans are going to move into this paradigm where they're only doing creative things for their own sake. And I think that's really the highest product that a human can do. But again, that's just my opinion. And this video isn't about philosophy. We're meant to stay on secular technology trends. So I'll do my best to do that. But in any case, if we do reach human level general intelligence by 2030, it's going to completely change how we think of work. Everything we know about the economy is going to fundamentally change, and I think it will completely change capitalism at its core. Okay, now we're on to biotechnology, and this is one of the most beautiful changes that I want to talk about in this video. So current medicine is reactive, it's one size fits all. That is, the medicine that you give to one person, you give to all the other patients with that disease, and it's also imprecise. So we have antibiotics that kill bad bacteria, but also good bacteria. We have cancer drugs that kill cancer cells, but also kill healthy cells, and that's why chemotherapy is so hard for people to go through. But we're moving into this era of smart medicine, of programmable medicine. Programmable medicine is preventative. That is, it can stop disease before it even occurs. So we already know that some of our genes, some of our genetic code, that's like the biological code that makes up a human being, just like computer code makes up a software program. We know that some of those genes cause disease later down the line. So what we can do is, once we know what gene that is, we can go in with genetic therapies and change that gene to make it normal and to make it so that we can prevent cancer or some other diseases in the first place. Now, following this, there's also this idea of personalized therapies, where you could have a drug that is engineered to work most efficiently with your unique genetic code. This is such a feat of technology and engineering that the cost to sequence a human genome in 2001 was $100 million, and it took over a year. And now the cost to sequence a human genome is $1,000. So we went from $100 million 20 years ago to now $1,000 to sequence a human genome, and that's what's driving this trend in genetic therapies. In 2023, the US and the UK, for the first time, approved several genetic therapies. So now several genetic therapies are on the market. That means that diseases that were previously incurable are now curable with these genetic therapies. This is an incredible thing, and a dozen or so more genetic therapies are expected to be on the market by 2030. All right, so now let's talk about manufacturing. Think about the physical products that we can buy. They're all standardized. Anything that is mass produced, for the most part, is standardized. It has to be uniform and similar to one another, but the paradigm is going to change with 3D printing farms. So 3D printing changes the manufacturing paradigm because it allows for us to mass produce things in a customized, personalized way. So think about e-commerce on demand, where you design your own sneaker and you order it in the exact size that you need. And this is a one-of-one product that right now could cost tens of thousands of dollars to create. I don't know. But in the future, it's just going to be the cost of a normal pair of sneakers. And so this on-demand printing changes the paradigm. But then also we have on-site printing, where you could just have a 3D printer at the location where a product or a part is needed and print that there. And so you don't need to ship the part from this central manufacturing place on the other side of the world. And the use cases for 3D printing are expanding. So a really interesting one I want to point to is by a startup company called Relativity Space. They're using metal 3D printing to 3D print reusable rockets. And so traditional rocket manufacturing methods, it could take years to manufacture a rocket, but this 3D printing process has it down to 60 days. It simplifies the amount of parts in the rocket by 90%. And so this faster and simpler method for creating a rocket is going to reduce the cost by 30 to 80% to create that rocket. Now let's talk about financial technologies. And to be honest with you, I never thought about financial as a technology. I never thought money as a technology. But when I started to learn about Bitcoin, I realized how much was wrong with our current financial system and our current fiat currencies, and realized how the blockchain and cryptocurrencies could really improve things from here. So starting with, what are the problems with our financial system? Well, it's a patchwork of hundreds of fiat currencies and thousands of banks that really don't play well with each other. The user experience of a transfer is that it's going to cost you quite a bit of money to send things internationally. Transfers can still take days to weeks to clear. Even though our money seems digital to us, why would it still take days to weeks to clear for things when all of our other digital interactions are instantaneous? Now let's talk about accessibility. 1.4 billion adults, they are unbanked, which means they can't securely save their money or participate in the modern economy. And the last thing that is a little bit deeper, so I don't want to go too deep into it, but it's the fact that governments inflate their currencies. This is so the government can print as much money as they want in order to fund what the government is doing. And of course, this funds things like corporate bailouts that you might not agree with or wars. But the real problem with the governments arbitrarily inflating their currencies like this is that when you increase the amount of money supply, you make each unit of currency worth less. But we're entering this open financial paradigm, and Bitcoin was the first step in this direction because Bitcoin is this borderless payment network, basically. And a lot of people don't use it for payments, but that's besides the point. So Bitcoin, anybody can download a Bitcoin app and save their money in it or make transactions in it that settle near instantly to anywhere in the world. Bitcoin is open source software, so any application can integrate Bitcoin into their software, as X has recently done with Bitcoin tipping. And that enables you to connect into the Bitcoin network and interact with anybody in the Bitcoin network. So it's totally interoperable. Bitcoin is decentralized. An independently acting network of global computers are securing the currency on top of it. Don't get too caught up in the details with that, but just understand that there's no single government or no single company that controls the Bitcoin currency. Also, Bitcoin is scarce. This is the idea of digital scarcity, which is a totally new concept to human beings and difficult to wrap your head around. It's this idea where a blockchain makes it to where you can't create more of a digital thing. So there's only ever going to be 21 million Bitcoin. This is like how there's only ever going to be so much gold on Earth. This is why gold is a scarce physical asset and Bitcoin is a scarce digital asset. And the implication of this is that it solves the monetary inflation problem. No government could ever create more Bitcoin. Now let's talk about devices, and the evolution of devices might be one of the most interesting technology trends for product designers. I think we're all aware that computers started with the command line interface. You had to know this programming language and exact syntax in order to control a computer, and then Apple created the graphical user interface, which made it computers accessible to almost everyone in the world. And now we're going into this linguistic user interface, or LUI paradigm, where we're going to control computers solely through natural language alone. ChatGPT's linguistic user interface was the fastest adopted technology ever. Over 100 million people downloaded or started to use ChatGPT within 2 months of its launch. And so this speaks to the intuitiveness of using natural language and an AI assistant like this. So if the graphical user interface gave everyone access to a computer, then linguistic user interfaces are going to make everyone super powered with a computer. And the average person is going to be just as good as the best programmers and digital artists are today, because you can interact with it completely intuitively just with natural language. And people can speak 3 times faster than they can type. So this is going to move many devices into a voice-first paradigm. Now let's move on to vehicles as an innovation platform. Most of the vehicles right now are human-driven. They're human-operated machines. So think of everyone in the world that is employed to transport items around the world. Think of how many people are employed by Amazon to get things from point A to point B, and you have truck drivers and you have planes that are shipping things. And think of all the transportation. We have ride-sharing apps like Uber and Lyft, where you can hire thousands of people driving around in your city to take you from one place to another. But if we think about it, we're really bad at split-second decisions. And so we're moving to this robotics-driven paradigm where robots and AI are simply going to be better at us and safer than us and even cheaper than us to operate these vehicles. So we're really close to fully autonomous vehicles. We are expected to have stage 5 fully self-driving cars by 2030. And obviously the company to look at here is Tesla and their development of Tesla Autopilot. And when you think about it, once we have cars that can completely drive themselves, this is going to birth a robo-taxi economy where all of the Uber drivers and Lyft drivers, all of our ride sharing is going to get replaced by robotic taxis. And this is also going to completely change delivery. So for cross-country deliveries, we're going to use autonomous trucks, which are soon going to be cheaper than rail by 2030. And then also you're going to have rolling robots and drones for last mile delivery. So like Uber Eats is going to be taken to you by a drone or some rolling robot. And the last trend to be aware of in vehicles are rockets. Rocket launches are getting much cheaper now that we have reusable rockets thanks to SpaceX. And so this could make recreational space travel a thing in the future. And it's also going to allow us to launch more satellites into space, which connects to the connectivity trend that I talked about before. All right, we're now at the final innovation platform. This is the virtual platform and our virtual worlds. So in my opinion, the metaverse is already here, but a lot of people just don't think of it as the metaverse. So what I mean is that billions of people every day interact in digital spaces. You check your email, you check social media. A lot of people, even hundreds of millions of people, are commuting to work on Zoom every day. And then also you have 600 million monthly users who visit virtual worlds like video games and digital classrooms to play and learn. So again, I say that the metaverse is already here, but the reason we don't think of it as the metaverse is because it's not immersive like we would think a metaverse should be, and it stops when we leave our computer. And so the future paradigm that we're heading to are these advances in augmented reality and virtual reality that are going to make our virtual worlds today seem super primitive. I think we all get the idea that the metaverse is going to be experienced in part through these next-gen spatial devices, like you have Apple Vision Pro, but then also you have these augmented reality lenses like Meta Ray-Bans that are going to blend the virtual world and the private worlds together. So when I'm out for my walk and I want to make a text message, then I'm just going to talk to an assistant and I'm going to see the words typed out at the bottom of my sunglass lenses. And VR headsets are going to become more immersive. They're going to become higher resolution. Haptic feedback is going to get better. They're going to just become more ergonomic and easier to wear. And the VR experiences are going to become more lifelike. So recently Lex Friedman had on Mark Zuckerberg, who demoed these new facially realistic avatars where when you talk, the mouth of your virtual avatar is talking and it gets all your eyebrow movements and stuff. And so this VR experience is more lifelike and more immersive, and it's going to be so much better than Zoom. So right now Zoom is just this flat 2D depiction of people and everyone's getting tired of Zoom. But you could imagine interacting with people for work in the metaverse with these facially realistic, highly realistic avatars in the metaverse, and that this is going to make virtual collaboration much better than it is right now. So there you have it. That's the macro tech stack. That is technology in a nutshell. This has been my best attempt at zooming out and explaining what I see as the technology landscape and how I think everything is going to change by 2030. Of course, it's not perfect. It's an oversimplification. And if you see other technological platforms or trends that I didn't talk about, then please leave them in the comments. If you liked the information that I talked about, but you want a slower, more in-depth way to consume it, then you can download the full macro tech stack. There's 86 cards in the deck for free, and just look at the description below for that link. Also, if you like this kind of thing and this kind of information inspires you, then you might consider joining the Alt Innovators community. So the Alt Innovators community is a place where you can connect with people to potentially spin off companies and products, but also it's meant to help you get a job working on the problems and working with the technologies that most interest you. But thank you all so much for watching. Thank you for continuing to support me in creating this educational and technology content, and I hope you all have a great day.